What's up? It's Vince, and no, this is not an extra episode of the RR Show. What it is an episode of Everything Everywhere. It's a podcast I suggest you check out on this podcast platform. Wherever you're listening, just go right now and check out Everything Everywhere. This is a full episode that I'm dropping. You're welcome, by the way. I'm dropping a full episode of Everything Everywhere in your feed right now so you can check it out. This is actually a really fun episode that I hand-selected myself that is about the wow signal. And believe me, it's kind of creepy and fun. Makes you think, doesn't it? Is probably what you'll say at the end of this episode of Everything Everywhere. So, again, Everything Everywhere. Check it out wherever you get podcasts. And I'm going to can it right now because here's this special episode of Everything Everywhere.
On August 15th, 1977, for a period of 72 seconds, the search for extraterrestrial intelligence had its greatest moment. A signal was received like none other before or since. However, in the over 45 years since the signal was recorded, astronomers have been unable to relocate it or even figure out what it was. Learn more about the WOW signal, why it was important, and what it could have been on this episode of Everything Everywhere Daily. In a previous episode, I discussed the Search for Extraterrestrial Intelligence, or the SETI project. To very quickly summarize, SETI was established to try to find signals from extraterrestrial civilizations using radio astronomy. Why try to detect civilizations using radio waves? Different wavelengths of light travel through space differently, and if you remember back to my episode on the electromagnetic spectrum, radio is just a form of light. While space is a near vacuum, there are gas and dust molecules that can inhabit interstellar space, which can block or absorb certain frequencies of light. There are certain frequencies in the microwave range from about 1 to 10 gigahertz, which can pass through relatively unimpeded. Frequencies above this range tend to get absorbed in the atmosphere or in interstellar space. Frequencies below this range tend to be drowned out by the enormous amount of radio waves created by the core of the galaxy. The noise in this region is so great that it would be difficult to filter out a real signal from the noise. The band where communications would be possible, not being drowned out and not being absorbed, is known as the microwave window. So if we were to communicate with some civilization far away, this is the most likely place to check for messages. However, simply looking for radio waves really isn't enough. Back in 1967, radio astronomers Jocelyn Bell and Anthony Hewish discovered something unexpected. They found something at the same point in the sky that pulsed with a signal every 1.337 seconds. Its signal was so regular that it was actually more accurate than atomic clocks at that time. At first, it was thought to be a signal from an extraterrestrial civilization. However, they soon found others like this and realized that it was a natural phenomenon. What they had found were dubbed pulsars, which stand for pulsating radio source. They result when extremely rapidly spinning neutron stars emits radio waves from its magnetic poles. It's basically like a rapidly spinning lighthouse, and we can only see the signal when the beam of light hits us. In addition to spinning rapidly, it also tends to emit radio waves over a rather large region. In fact, spewing radio waves over a large band of radio spectrum is pretty much a hallmark of naturally occurring radio sources. When humans broadcast radio waves, we tend to do so over very narrow bands of frequency. That is why you can listen to different radio stations so close to each other on the dial. So a good place to look would be in the microwave window, and a good thing to look for would be some sort of narrow band communication. However, there's one other thing. The microwave window is still pretty big. 1 to 10 gigahertz is a lot of spectrum to search. Within that window is a smaller range of frequencies that hold special significance. Hydrogen is the most abundant element in the universe by a wide margin. When excited, hydrogen can emit electromagnetic waves at 1.42 gigahertz at a wavelength of approximately 21 centimeters. Another important molecule is the hydroxyl molecule, which consists of one oxygen and one hydrogen. It has a wavelength of 1.612 gigahertz to 1.72 gigahertz. What do hydrogen and hydroxyl molecules make when you put them together? Water. This range from 1.42 GHz to 1.72 GHz is known as the watering hole. This is a relatively short range of frequencies in the microwave window that correspond to two very important and common substances, hydrogen and water. I mention all of this because there is a very specific place where astronomers are looking, and there is a very specific thing that they are looking for. They aren't just randomly listening to every radio signal in the sky. If there's some extraterrestrial civilization trying to send messages, a very narrow band signal somewhere in the watering hole seems like a very good place to search. With that, the story now turns to Ohio State University. In the 1960s, they created one of the largest radio telescopes in the world, known as the Big Ear. If you've ever seen a radio telescope or a photo of one, the Big Ear looks nothing like it. The Big Ear was the size of a football field. On one end was a 33-meter-long flat structure that could tilt up and down, but not right to left. On the other end of the field was a parabolic structure that didn't move at all. And in between, the field was covered in tinfoil, and in the middle there were two radio receivers. The way it worked was that the flat end would bounce radio waves from space towards the parabolic structure. The parabolic structure would then focus the radio waves into the radio receivers. The difference between it and a parabolic antenna was that you couldn't point it anywhere you wanted. You could only adjust it up and down. However, that was okay because you could use the rotation of the Earth to move it right and left over time. The Big Ear was designed to conduct a survey of radio signals over the entire sky. The reflecting section would be set at a particular angle, and the Earth would revolve about its axis, allowing an entire strip of sky to be analyzed. They could adjust the angle and just do it again, and they could just keep doing it until the entire sky was covered. And that's exactly what they did. From 1963 to 1971, the Big Ear conducted the Ohio Sky Survey. They discovered almost 20,000 radio sources during this period. However, once the survey was completed, the Big Ear was no longer a state-of-the-art instrument. But rather than dismantle it, in 1973 it was repurposed for the search for extraterrestrial intelligence, or SETI. The events which are the subject of this episode took place on August 15, 1977. The way the system worked is that the radio telescope would listen for about 10 seconds near the 1.4 gigahertz frequency. An IBM 1130 computer would then take 2 seconds to analyze the data. It would then output a single alphanumeric character to indicate the strength of the signal to the background noise. If the signal it heard was between 0 and 1 standard deviations from background noise, it would just print a space, like literally nothing. If it was between 1 and 2 standard deviations, it would publish a 1. After 9, it used the letters of the alphabet. A was 10, B was 11, and so on. It would print out the results on paper, which humans would then analyze to look for any patterns. Most of the printouts were nothing but spaces and the number 1, with an occasional 2 and maybe a 3. Several days after the recording took place, a SETI volunteer physicist by the name of Jerry Eman was reading the recordings taken on August 15th at 10:16 p.m. Eastern Daylight Time. On the printout, amongst the blank spaces 1s and 2s, were 6 consecutive characters that had never been seen before. 6EQ-UJ5. This was an enormous, narrow band signal located right near the 1.4 gigahertz frequency. The exact thing that SETI researchers had been looking for. Jerry Eman took a pen and circled the data on the printout and wrote next to it, "WOW." Hence the name, the WOW signal. I should note that 6EQ-UJ5 was not some sort of code sent by aliens. 6EQ-UJ5 is just how the computer system recorded the strength of the signal. The 6 characters represented a full 72 seconds of the signal. The U part of the signal was the point where the signal was a full 30 standard deviations above the background noise. There is no known natural way for a narrow band signal of that strength to be sent. So the first question was, where did the signal come from? At the time the signal was recorded, the telescope was pointed towards the constellation Sagittarius in a particular section near the Messier object number 55. Messier objects are points in the sky that aren't stars and are usually nebulae or galaxies, and they'll be the subject of a future episode. The area the signal came from couldn't be pinpointed exactly due to the dual receiver setup of the Big Ear. However, in the part of the sky we can narrow the location down to, it contains over 1 million stars. While we know roughly where the signal came from, the other big question is, what was it? If there was any information contained in the signal, it couldn't have been recorded because that wasn't what the radio telescope was set up to do. Information in a radio signal would be sent through modulation of the signal, and as the system was set up to average everything out over 10 seconds, the modulation would have been lost. No other radio telescope has ever detected anything like this in that area of the sky. There have been at least 50 different attempts to try to find the signal in the same patch of space. In May of 2022, several radio telescopes were pointed at this patch of sky for an extended period of time, and they found nothing. One theory holds that this was in fact some sort of extraterrestrial signal. However, whoever sent it is sending the signal out like a lighthouse beam. They're covering the sky, and our observation sweeping the sky just crossed their beam at the right point for only those 72 seconds. If this is the case, then why haven't we seen the signal since then? One problem could be that we're only looking intermittently. One of the longest searches ever conducted was done by the Very Large Array in New Mexico, which only looked for 14 hours. One proposed theory that made the news back in 2017 was that it could have been a comet that it saw. That theory has pretty much been discredited because it wasn't actually in that part of the sky at the time of the recording, and comets don't behave that way. The other theory, which seems the most likely, is that it came from some human source. The 1.427 gigahertz frequency is supposed to be dedicated to radio astronomy. However, it's possible somebody was broadcasting in that part of the spectrum, even if it was accidentally. It could be that there was some piece of space junk that reflected a radio signal, which was picked up by the ultra-sensitive instrument. The truth is, we don't know. All we do know is that for one brief moment in 1977, the exact sort of strong narrowband signal at the exact frequency astronomers were searching was recorded. And since then, it has never been seen again. Wow. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Thor Thompson and Peter Bennett. Today's review comes from listener Zell McGran over on Apple Podcasts in the United States. They write, "So great! I love it. I have listened to every single episode twice." Thanks, Zell McGran. I'm happy to announce that having listened to every episode twice, you have achieved Elite Platinum status in the Completionist Club. As an Elite Platinum member, you will get priority seating at the Completionist Club, you'll get to use the Elite Platinum member entrance, and 24-hour access to the Completionist Club concierge. Remember, if you leave a review or send me a boostagram, you too can have it read on the show.